Asynchronous and synchronous transmission. Asynchronous strategy is to avoid timing problem by not sending long uninterrupted streams of bits. Synchronous, a block of bits is transmitted in steady stream without start and stop codes. Asynchronous, data are transmitted one character at a time, where each character is 5 to 8 bits in length. Synchronous block may be many bits in length. Timing or synchronization must only be maintained within each character. To prevent timing drift between transmitter and receiver, their clock must somehow be synchronized. Provide a separate clock line between a transmitter and receiver. Embed the clocking information in the data signal. The receiver has the opportunity to resynchronize at the beginning of each new character. Frame, data plus preamble. Transmission impairments. Signal received may differ from signal transmitted, causing analog degradation of signal quality, digital bit error. Most significant impairments are attenuation. Signal strength falls off with distance over any transmission medium, varies with frequency. Attenuation means signal strength falls off with distance over any transmission medium, varies with frequency. Equalize attenuation across the band of frequencies used by using loading coils or amplifiers. To equalize the attenuation across the band of frequencies used by to equalize the bandwidth among various frequencies, we use coils or amplifiers. The received signal strength must be strong enough to be detected, sufficiently higher than noise to be received without error. Then strength can be increased using amplifiers or repeaters. Delay distortion occurs in transmission cables such as twisted pair, coaxial cable, and optical fiber. Does not occur when the signals are transmitted through the air by means of antennas. Occurs because propagation velocity of signal through a guided medium varies with the frequency. Delay distortion. Various frequency components arrive at different times, resulting in phase shift between the frequencies. Particularly critical for digital data since parts of the one bit spill over into others, causing inter-symbol interference. Noise. Unwanted signals inserted between transmitter and receiver is the major limiting factor in communication system performance. Unwanted signals inserted between transmitter and receiver is the major limiting factor in communications system performance. Categories of noise: thermal noise and intermodulation noise. Thermal noise, due to thermal agitation of electrons uniformly distributed across bandwidth, referred to as a white noise. Thermal noise is also referred to as a white noise. Intermodulation noise, produced by non-linearities in the transmitter, receiver, or interwaving transmission medium. Effect is to produce signal at the frequency that is the sum or difference of two original frequencies. Effect is to produce signals at a frequency that is the sum or difference of two original frequencies. Crosstalk. A signal from one line is picked up by another. Can occur by electrical coupling between nearby twisted pairs or when the microwave antennas pick up unwanted signals. Impulse noise, caused by external electromagnetic interference, non-continuous, consisting of irregular pulses or spikes. Short duration and high amplitude, minor annoyance for analog signals but major source of error in digital signal. What is impulse noise? Impulse noise is caused by external electromagnetic interference, non-continuous, consisting of irregular pulses or spikes, short duration and high amplitude, minor annoyance for analog signal but major source of error in digital signal. Thermal capacity. Then Nyquist bandwidth. In case of channel that is noise free, the limitation of data rate is simply the bandwidth of the signal. If the rate of signal transmission is 2b, then the signal with the frequency is no greater than b is sufficient to carry the signal rate. Given bandwidth of b, the hardest signal rate that can be carried is 2b. For binary signals, the data rate that can be supported by b Hz is 2b bps. With multi-level signaling, the Nyquist formula becomes C equal to 2b log m. Data rate can be increased by increasing the number of different signal elements. This causes the burden on receiver. Noise and other impairments limit the practical value of M. Shannon capacity formula. Considering the relation of data rate, noise and error rate, faster data rate shortens the each bit, so burst of noise corrupts more bits. Given noise level, higher rates means higher errors. Shannon developed formula relating these two signal to the noise ratio in decibels. SNR equal to 10 log 10 signal by noise. Capacity C equal to P log 2 1 plus SNR. Theoretical maximum capacity get much lower rates in practice.